Okay, 1.5. Describe the forces experienced by a current carrying loop in a magnetic field and describe the net result of the forces. So what is this demonstrating here is what happens in a motor, and we're going to demonstrate this by looking at the diagram on the right hand side next to the equation. So let's look at this, and you need to know a few things about this diagram here. You've got a magnetic field going from north to south. You've got arrows for I indicating current, which is key in a moment. You're going to figure that out. And there are a lot of arrows indicating that magnetic field going from north to south, like I just mentioned. So the two key things that you need to know for this scenario is you need to know the current. So we're going to use the right-hand palm rule in a moment. You need to know your magnetic field, and that's key for the directional force. So let's use the right-hand palm rule. You've got your current, which is your thumb, and your 4 index fingers, which represent magnetic field. Your palm is going to represent the force coming out of the palm. Okay, so let's look at this scenario here. If you look at the conductor closest to the south, or the S magnetic field there, the current is going into the webcam. So I'm going to point my thumb into the webcam. Now, magnetic field is going from north to south, which is going in this direction. And you can see my palm automatically indicates the force going down. And you can see the direction of rotation is going in a clockwise direction. Okay, to verify that, the current is going in the loop, around the loop, and then towards me again. So we're going to point my thumb in my direction here, pointing towards my neck. We're going to put my fingers going in the magnetic field, which is going the opposite way to where I was just holding it. And you can see my force is going up towards the ceiling, which is showing you that's true, that it's going in a clockwise direction. Now, the other thing you might need to know for your HSC is the formula there in the middle of that slide. You've got torque, you've got number of coils, which is going to affect torque. You've got the magnetic field strength. You've got the current in a wire, you've got the area in which that is being possessed, and you've got the angle, and that relates back to 1.1.